Hello, and I'm Srivarsha, and I'm going to present on the topic application of context-free grammar in speech recognition. First, let's start with understanding what is context-free grammar. A context-free grammar in computer science and linguistics, a context-free grammar is a formal system used to describe the syntax or structure of a language. It helps define how strings of symbol can be generated or passed in a language. A CFG consists of terminals, that is, the actual words or symbols that we use in a language, like cat or dog. Next, the non terminals. These are the abstract categories, example, noun, verb. And next one is the production rules. These define how a non terminal can be expanded into terminals or other non terminals. And finally, a start symbol, which is the starting point for generating sentences. Structure of CFG. Here is a quick breakdown of components of CFG. Let's take a simple example of sentence structure where the sentence produces sentence non-terminal produces noun phrase non-terminal plus verb phrase non-terminal. The noun phrase non-terminal in turn produces article terminal and noun terminal, and verb phrase non-terminal produces verb terminal and noun phrase terminal. And the set of rules help generate sentences like the cat eats. The article here is the, noun here is cat, verb here is eats, and noun phrase is fish. Next, handling ambiguity in speech. Actually, as you can see in an example, CFG can help us describe the structure of natural language. It can tell what makes a valid sentence and what doesn't. For example, CFG ensure that phrases like the cat sees a dog follow the right word order and grammatical structure. Now let's jump into the introduction to speech recognition. Speech recognition is the process of converting the spoken words into text. It is used in applications like voice assistance, transcription service, and automated customer services. But for the machine to understand speech, it needs to make sense of the sequence of words and their structure, which is where CFG comes in. The challenges in speech recognition includes the ambiguity, noise, and grammar handling. However, speech recognition has its own challenges like noise, different accents, and varying speech patterns. CFG helps by filtering out invalid inputs. For example, if there is a background noise that sounds like a word, the system uses context to decide whether the word makes sense in that situation. Next comes the why CFG used in speech recognition. CFG plays a huge role in defining the structure of spoken commands. For instance, let's imagine a voice command system. This is the example. Command non-terminal producing action and object non-terminal action non-terminal in turn produces open or close or play terminals, and object non-terminal produces file or video or music terminals. Using these tools, the system can recognize the commands like open file, close video, or play music, knowing exactly what the user wants. And also, the CFG helps in error detection and correction, and it also improves the accuracy of speech to text conversion. Moreover, the main role of CFG is in reducing the ambiguity. Homophones like ice cream and ice cream can confuse the system, but by using the CFG, we can add rules and context to disambiguate these phrases. For example, if the user says ice cream, the system can decide that it's more likely to be referring to ice cream as in yell based surrounding words. Next is the passing in speech recognition. There are two types of passing, top down passing and bottom up passing, where the top down passing tries to match the sentence from the start, and the bottom up passing starts with a word and builds sentence structure, helps understand the grammar based sentence construction. And this is the example of CFG in passing speech. And this is the rule breakdown, CFG rule breakdown, where the sentence non-terminal produces a verb phrase non-terminal, which in turn produces verb terminal and noun phrase non-terminal. And the noun phrase non-terminal produces article terminal and the noun non-terminal. In this example, we can see book a flight to Paris. This example can be breakdown with this CFG rule breakdown. Next is the application in real world speech recognition. Interactive voice response systems are another area where CFG shines. These are used in customer services hotlines. For example, a customer might be asked, press 1 to check your balance, press 2 to speak to an agent. The system uses CFG to ensure it recognizes the valid responses from the customer. And also the real world applications include the Siri, Alexa, Google Assistant. The CFG helps these systems recognize and process the voice commands efficiently. For example, when you ask what's the weather today or set an alarm for 7 a.m., CFG ensures these requests are understood correctly. The limitation of CFG in speech recognition includes that it cannot handle the context dependent meanings, and it struggles with slang and informal speech, and its limited ability to process real world speech errors. Yeah. Next is the speech to text system. Speech to text systems also rely on CFG to ensure that spoken words are transcribed correctly into the text. If someone says, the quick brown fox jumped over the lazy dog, the CFG helps recognize the sentence is grammatically correct and accurately transcribe it. The advantages of CFG in speech recognitions are the better accuracy. It ensures only valid word sequence are recognized. Faster processing. CFG reduces the search space for valid word combination. Context awareness helps resolve ambiguities like differentiating homophones. Customizability. CFG can be tailored to specific use cases like medical speech recognition or legal dictation. Future of CFG in AI speech recognition. Looking ahead, the future of speech recognition is quite exciting. With advancement in AI and machine learning, CFG can be enhanced further. The recognition systems will be more dynamic and contextually aware, offering more accurate and reliable results. And then the conclusion. To conclude, see, context-free grammar is fundamental to speech recognition. It helps create structured, grammatically valid language models which improve the accuracy and efficiency at speech recognition system. As technological advances, CFG will continue to play a crucial role in making voice interaction smarter and more intuitive. More intuitive. Thank you for listening.